It's time for a technical autopsy on components out of a dishwasher. Firstly, the door latch mechanism, which can actually push the door open at the end of the cycle to let the steam out, and also the control system. And the message that came with this was, "Hi Clive, as mentioned on Patreon, please find and close the control board and door lock with automatic door opener. I hope you find some use for them. The issue I had was the dishwasher door would not pop open automatically at the end of the wash cycle to let the steam out so the dishes dried properly. The dishwasher is Zanussi brand. All the best, George." So this already, I think George may have had a go. There's bits of plastic here. The service engineer came out to fix the machine, and just because he wasn't sure what was causing it, he changed the control module and the door lock mechanism itself. And looking at this, it's got two heavily sprung claws here. And if you push maybe a screwdriver into it, like the door interlock bit, it pushes in back, and then it clicks in, and then to get it out again, you can just pull the door open. It's not one of those that it locks the door and you can't open it. It is the you can open it any time. All it does is just stop the cycle. But this thing also has what looks like a little switch mechanism here, and it can apparently push the door open. I'm not sure if this latches and then it pings. I can see something that could be a solenoid here. Let's just open it. That's the best bet. I shall use this. How does this clip on? It clips off like that. It has, this is where the plastic came from, isn't it? Oh, it's got a wee hinge thing that goes up and down. And it says plugs inside. Oh, right, okay, that covers both the connectors. Right, okay. I'm guessing, I could be wrong, that this is a switch from where its location. No, it says 28 volts DC 200 milliamps, so that's a switch. And the other one says 220 to 240 volts. It's too small for a solenoid. It could be a solenoid, but I'm guessing, as with most of these things, it may be a, I hope there's not a huge powerful spring in this, it may be a thermally actuated wax motor. They call them wax motors. You could call them a linear actuator. Oh, then I don't think that's going to come out. But they call them wax motors because a motor is a device that converts energy from one energy to another, so they call it that. It does have the little red plunger in here interlocked, and the big spring at the back that makes this look like a wax motor. It also says 220, 240. I think we have to power this up. I think we'll power this up right now and see what happens, and then we'll get the rest of it open. I could also maybe jam the meter in here, set it to continuity, and see if we can get the actuate the switch from the other side. This is probably, I'm going to regret this because it's very fumbly to get connections in here. So let's put the continuity tester in here. Oh, I'm not sure if I'm going to get this. The connector is, as is so common in these machines, these devices, it's made down to a price. So it's a very simple connector. It's not like you can probe it easily either. Oh, you know what? We'll investigate that after. I don't think we're going to get into it. However, what I can do is I can pause and I can stick some connectors on here, and we'll see what happens with this, if it does anything interesting. One moment, please. Okay, I've added some spade connectors onto this. I've got a plug on it. I'll zoom up and we'll take a look at this. We'll see what the power does, but there'll be a delay. If this is a wax motor inside, it will be quite slow in operation, but we'll see what happens. So I shall zoom up here so we can get the hoppy and the wax motor in shot. And then I shall plug it in. I'll just get that into position here. So we're looking for this little red plunger to gradually move. Probably that way. I wonder if it pushes the door open. So 11 watts, I'm not sure what it peaks at, but that is typical for these things. Typically speaking, as it heats up, the current will go down. So this also introduces a time delay at the end. It's used in washing machines. It adds a time delay to allow the spin to stop. But they're very cheap. It's a really great way. They're incredibly powerful, these devices. Oh, I can see it moving. Can you see that gradually moving out there? The power's dropped to about 7 watts. That's fairly typical. Let's zoom in this so you can actually see this. I shall gently nudge this over that direction. And we can see a distinct movement in here. Oh, that's quite fast. It's quite a long throw as well. It's quite a long stroke. I'm guessing it'll go so far, that'll be what this is for. I bet once it reaches the end of travel there, this spring starts compressing and it just basically takes up the difference. I'm not seeing any movement of that yet, unless it's actually still moving. The power has dropped to about 4.5 watts, which is fairly typical. It seems to have stopped. But I was expecting this plate to move back here at the side. Right, tell you what, this is boring if it's not going to do anything exciting. I was expecting to see some movement here as it compressed this spring, but it's not. I guess that's all we're getting. Right, tell you what, then I shall unplug it. And when I unplug it after a sort of time delay, this will retract. But in the moment, now I've unplugged it, that little lever that was loose has pushed forward. So whatever goes into here must be a sort of circular pin to push in, but it must have a little sliding pin or a tab that goes in here. And it's this unit pushing forward in that actually pushes that and actually basically pushes it beyond the catch and makes the door just pop open. All right, okay. Rightio. I shall get the hoppy out the way and I shall take this to bits. Is it going to be red hot now? It's fairly warm. Yeah, I'm guessing that if it had gone any further, it would have pushed that back. We could probably lift this whole mechanism out. Oh, I can push the whole mechanism out. There is the wax motor. If you want to see how a wax motor works, you can find a video about that, not just on my channel, but also if you search for wax motor, you'll find it on Abe's channel as well. And this little thing here, well, a little thing, it's powerful. Jeez, that is really powerful. Lots of forces involved here, but this little motor here would easily lift my weight. It's just the way they work is so simple. It basically involves expansion of wax in a little hydraulic cylinder, and when it's heated up, the liquid expands quite greatly and it applies massive force. Rightio. Part of me says I should take that out. No, I'm not going to take that out. It looks dangerous. Just like these big springs here, but is that going to stop me? No. Oh, I can feel it's very springy feeling. It's very springy indeed. Am I going to get hurt? Big springs are always fun. Some industrial equipment has just the worst springs in the world. So this can go up as well. And this will reveal the switch mechanism because I can feel the little switch cover going up. Anything else I need to know about to get this out? Oh yes, another tab at the back. It's all held together by these springy tabs. Is this it? Almost. They're quite well engineered. They're actually designed so they won't just unclip. I looked up the cost of this component. It's about £30, which isn't too bad. It's one of these things that if you're fixing the machine yourself, and only really technical people would do that. Oh, this is kind of want to open now, okay. So there is the actuator that pushes that tab out. Here's the switch. The switch actually rocks. Oh, right, and it is that little arm, that same little tab there that pushes in when the thing is locked. It pushes it out, but it also swings this little cantilever. So when you actually slam the door shut, it pushes that switch in. Let's see if we can pop the switch out. Let's see if we can open the switch. Is there any point opening this switch? How is the assembly in this? I don't know if this is going to open easily. It looks like it's all pressed together fairly solidly. Having said that, if it's faulty, you would want to open it. Let's see if we can actually work out how that happens. Oh no, it really is all moulded. That's not terribly exciting. I shall try opening it anyway, because let's face it, this thing is potentially gubbed. I shall use unreasonable force. No, the unreasonable force is not working. It really is latched in big time. So okay, so you just buy a replacement. Right, okay, we've taken that to bits with its big, huge springs. Ooh, that's a bit scary. Let's take a look at the controller. So this thing says 5 volt DC, 392020. It's not that old. Oh, this must have been under guarantee. That's good. It's got a button, 2 buttons. These, I'm not sure what these are. It's got little flaps. It's got a hinge. This might just be a remote display unit. That silicon has to come off. Ooh. Ooh, big box, tiny circuit board. Is this kind of like been designed for... Is this just a controller, or is this just a remote display unit? Let's see if we can pop this out. There's light guides. 3 little light guides down here with 3 little LEDs, more little LEDs along here, just 3 buttons. What's that? LS1 loudspeaker. Oh, it's a peeper. And the chip, right, tell you what, I'm going to explore this. I'm going to take a look at it. Oh, J-Flash. That, I bet that connector's not. That connector is not. This is the one for programming it in situ, not in situ, but actually at the factory before putting it into the unit. So this must be a multi-purpose board. Right, tell you what, one moment, I'm going to investigate this. Well, this is one of the most frustrating circuit boards I've ever tried to reverse engineer. I can kind of work out what's happening. It's got various input-output pins that have diode pairs going to the positive rail and the negative rail for protection against external influence. But it's using absolutely microscopic tracks that keep jumping from one side. Look at all the plated through holes. Tracing this circuit board is a nightmare, and it doesn't help the fact that there's a set of test pads up here that does all the input-output pins that by the time you think, I'm tracing it, I'm finally getting into the circuitry, it's just the little test pads. Very frustrating. But nonetheless, despite having spent far too much time on that, I can show you this working, because it will work on its own, but it goes into alarm mode. Well, I'll show you. I'll put this out the way. I shall zoom down a bit. I shall connect the crocodile clips to this, and I shall give it 5 volts. So I'll zoom down onto it. It's about to beep, by the way, but I'll tell you when it's about to beep. So I'll zoom down. Honestly, I'd hoped to give you more than this, but unfortunately, it is just a nightmare to reverse engineer. I'd need to actually draw this out on big sheets of paper and then actually trace each line out and have lots and lots of copies and trace each function out individually. It was very jam-packed. So at the moment, it's got this LED's flash on and off. If I press this button, it toggles that LED on and off. Not sure what that mode is. When you press this button, it steps along the features, the feature LEDs. And if you press this button to start it, and I'll warn you now, it's about to start peeping. I'll cover that. So it's going into alarm mode because it doesn't detect the inputs that it's expecting. It may repeat that code, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 beeps. That probably means absolutely nothing there. It may mean it's actually lost communication with the other unit. So here's my guess about how this works. The incoming supply will go to a switch mode power supply and a power switching card. That will then send 5 volts up to this unit, but the switches will also come up to this unit for sensing. And it will have a data link back down to that power card so it can switch things on. And typical things that I'd expected to sense would be water fill level, thermostat, door lock, and possibly it might even have the NTC thermistor input, and also something like perhaps the a flood alert that tells it if there's water building up in the base of the unit. On the outputs, I would expect this to be sending data down to the water fill solenoid, the pump motor for pumping it out, the heater block, the wash motor, the soap release mechanism, and the door release interlock, that thing we took to bits earlier on. Basically turning on this little sort of wax motor. But I'd guess really the size of this box here and the size of the circuit board suggests that this may have originally, it may be a standard case, and it may originally have had quite a big circuit board in it, but now they've managed to get it down to this. So it's worth mentioning, all these pads here, you think, well, they've got 5 there and 5 there, so there's plenty of connections, but they're all linked to either side. So if this is 3 on this side, it's also 3 on the other side, probably just as part of the economy of making the connector. The switch here is also mass-produced ridiculously. The reason I couldn't get it apart is because it's just basically, it's 2 parts, the switch. It's the plunger mechanism here and the actual contacts. And this plunger mechanism houses a little spring. And there's another little spring that presses down it from the top. And when they push this in, when they assemble this, they push this in and then the actual connection pins get pushed in to lock this in place and actually act as electrical connections. So it must be moved into a couple of positions as each pin's pushed in. And literally the thing that's actually making the connection is this tiny little spring just springing against an electrical connection. So it will be plated in some way, I'm guessing, to make a good connection, but it is just a very simple connection. That's one of those components that will probably fail. Like all the components in dishwashers fail and washing machines are made down to a price. But there we go, it's interesting. This little connector here will be for, presumably for when they want to actually program this in the factory, they'll just slot it into a frame and it'll make connection with those, and then it'll be able to actually program the software for the particular model in the place. Some washing machines also have a programming port in the back that when you can either update the firmware while the machine's completely built, or in the case of putting a new controller in, you have to load it with the correct firmware for the particular machine for the features. But it's interesting. It's well compressed in the design. One thing that caught me, I was looking at all these transistors. They're partly for multiplexing the LEDs. I guess it may be designed to drive a larger display. But to get a number of LEDs without a high pin count, they have multiplexed them, so they are scanned. But there we go. It's an interesting thing. So I wonder what failed. I would guess, I wonder if it was mechanical in the door lock, because this plunger was working. And it's odd to change this, because to the best of my knowledge, this is working. So I wonder what was up. Maybe he changed the catch on the door as well. They probably just fired the parts cannon at it, because ultimately, if it's us trying to fix a machine, we can like swap this little bit, and then we can, you know, if we wanted to see, is it this getting the signal, you could actually take the spade connectors off, and knowing what it is, you could use a set of test lamps, and when it gets that bit of the cycle, it would actually power up, and you'd expect this to move out. So you'd see if at least power was getting there or not. But for the factory, for the maintenance guys, they're not interested in faffing around and trying this and that. They're basically wanting to get in and out, so it's just cheaper to bang in a new module and bang in a new lock and be done with it. But there we go, it was interesting. So thanks to George for sending that item. It was an interesting mechanism. I've never even come across the ones that pop the door open. I don't think mine does that. It definitely doesn't, in fact. You just have to manually open it afterwards. It doesn't just nudge it ajar to let the air circulate. But interesting stuff. Very interesting indeed.